Assalamu alaikum. I am Sahbaj Sarder, ID 191354331, Department of Software Engineering, Daffodil International University. My topic is potato leaf, early blight, and late blight disease detection using deep learning. Supervised by Miss Nusrat Tasnim Ma'am, Software Engineering Department, Daffodil International University. So, background. Agriculture is the backbone of our economy. We face a lot of loss in quantity of and quality due to lack of technology in our agricultural field. So my goal is to reduce the losses and bring the technologies in the farmer's hand. From my personal experience, as my grandfather was also an farmer, he used to face a lot of loss in quality and quantity uh, of the corpse due to lack of technology, and I have seen he facing many losses due to the lack of technology. He could not recognize which plant is disease affected or which plant is healthy in time. So the scope and my goal will be to reduce the chances of the diseases infection. My The scope of these projects are huge. If we can use the technology, the farmers are still don't know how to use these softwares or these technologies. We need to first award them, and then we have to create an UX or user experience easy and more interactive for the targeted users. There are two methods of collecting data. One by collecting by yourself or collecting it from any websites. I have collected this data by myself. I will be collecting this data. Objective: leaves of a plant can be used to determine the health of status of the plant. The objective of this work is to develop a system that will be capable to detect, identify the type of disease using deep learning. Stakeholders: the stakeholders are developer, user, and owner. Functional and non-functional requirements. Registration: user must be able to register. Login: user must be able to log in. Capture image, upload image, show result, clear image. User must have these abilities to use this software, and this is the functional requirements of this system. The non-functional requirements are accuracy. This system must have the accuracy. Complexity: the system must not be complex for the user, as the targeted audience are not that capable of using any systems or technologies. Consistency: the system must be consistent. Fairness: the system must have the fairness between the disease infected and non-disease infected leaves. Performance: privacy, reliability, usability, testability. The system must have these qualities and non-functional requirements for this system. So use case diagram. Here you can see the use case diagram. Here the left in the left we can see user, the primary actor. Here user is connected to registration, login, upload image, click image, show result, clear previous image. He will be able to do these things. And here you can see an include attribute, which is verify password. This is must for both system and user. Extend display login. Here, so here is the activity diagram of the system. Here you will I will be first capturing image, then I will put the photos in input image section. The If the leaf detection segment is successful, it will go to the next phase, or it will go to the Centralian segment, and you will bring back the into the input image section again. If the leaf detection segment is successful, then it will go to the filtering process where we will filter the data. Then we will enhance the photos and bring back the original quality and good quality of the photos. And then we will go to the segment section where the photos will be divided into segments. And then we'll go to the feature extraction where we'll collectively extract the features of a leaf, and we'll then go to classification photos using these features, and we will classify those leaves into various classes using the features. Then we will go to the stops page. Here you can see the user sequence diagram. We will first it will go to the user and then login phase, then take upload phase, and then it will go to the database or dataset. I will say. Then it will bring matched with data or mismatched data. If the data is matched with the original data, it will go to the user saying showing the disease. Or if the data doesn't match, it will bring invalid message to the user. Here you can see the entity relationship diagram. Here user has two attributes, user ID and password. It has one-to-one relationship with disease detector. It will first go to the capture image or upload image, then disease detector. Then it will go to the system with one-to-one relationship between them. There is a check section where and it will again go to the verify section and user section, and these two has one-to-one relationship between them. And the system has also a connection between database, and the database has two attributes, image class and image id. So here are the technologies I am going to use. I am going to use TensorFlow, convolutional neural network, data augmentation, and TensorFlow dataset for the model building. I am going to use TensorFlow serving and FastAPI for the backend server, both. I will use quantization and TensorFlow Lite for the model optimization. I will use React.js for the front end. Thank you so much. Assalamu alaikum.